Okay, so for 12, part A and B you were able to get, but we still need to have that first derivative in order to do the second derivative. So that would be like part of what you already did in A. Let me go ahead and just take the first derivative. I'll make sure it matches up. So we're doing low d high minus high d low over the bottom squared, and then we can clean it up. Okay, so my first derivative, this is x squared plus 1 minus 2x squared. So I really have like 1 minus x squared or negative x squared plus 1. Okay, and then the bottom is this. So does that look right, Mackenzie? Look good? Okay. Then we're going to the second derivative. It's easy to mess up a derivative, so it's good to check it as you're going. As we're doing low, and then d high would be just negative 2x. I'm going to shift this over so I can fit in. There we go, minus high. And d low, we need to pull the 2 down. Leave the x squared plus 1 alone, and it's raised to the 1 power. And then we multiply by the derivative of the inside, which would be 2x. Let me know if I mess something up here. Does that look okay? Okay, so this is our low d high minus high d low over the bottom squared. And I see something here that is something we haven't really done a lot, or maybe done yet in this class. Okay, when I look at these 3 pieces, okay, and I'm going to show you what 3 pieces I'm talking about. Let's highlight them. Okay, so this is one piece of what I've got. This all is like multiplied, so that's all another chunk, and then I've got this chunk here. Do you guys see how they all have an x squared plus 1 factor? So what we can do to help clean this up is like I can distribute or factor out an x squared plus 1 in the numerator, and wouldn't that drop this down to just the first power? And that would pull this out of there, wouldn't it? So if I factor that out of the top, 1's gone here and that 1's gone there, and if I factor it out of the bottom, I only have 3 left here, and then you can cancel that out. You see that? Okay, so just so we're aware, because I still saw this on some people's work for their quiz, I'm going to go back for a second here. You cannot go, okay, I'm going to cancel this with this and just make that a squared. You cannot just cancel out of one piece, okay? It's got to be factored out of that entire numerator. I did see that on some papers. You just got to be careful of how you clean stuff up. So I factored 1 out of here, factored this one out of here. That gives me that numerator piece, and factored 1 of them out of the bottom and canceled. Okay, so we've got that. Now I'm going to try to clean it up so that I can take and set this equal to 0 as my next step. So my numerator, if I distribute this through, gives me negative 2x cubed minus 2x. And then in the back, I'm going to put the minus out front, and I've got 4x here because that piece canceled, times 1 minus x squared. I'm trying to be careful so I don't end up messing something up here. So this is just my numerator right now. And I'm just doing some scratch work here. Is that looking okay? Let me know if I do something wrong. Okay, so our x cubes, a 4x cubed minus a 2x cubed is going to give me a 2x cubed, and then minus 6x. And then we still have the denominator, so this is going to be kind of my simplified form. And you don't want to multiply that denominator out. Like, really, stuff that's factored is so much easier to deal with, okay? So we want to keep stuff as factored as we can. And we could factor out the numerator if you wanted to here, like take a 2 and an x out, and it would be the same thing. So you could do that, but here's my second derivative, and I'm guessing, Mackenzie, we're having trouble cleaning it up there. Is that the case? So now that we have that, we would take and set it to 0, right? And then you're going to find where the second derivative is positive and where it's negative using the number line. Do you know how to finish it? Okay. So that one I'll leave up to you guys to finish. And if you're someone who still needs help finishing that, make sure you're letting me know, okay? But then we also have on here 14a. And 14, maybe we'll just do the full thing. So then we'll do all the stuff that we should have done for 12 here if we were doing it entirely, okay? All right, so I'm going to start 14 just right below here. And when I'm doing these questions in class, every single person who's sitting here should have these done on their paper, at least to where I've got them done, okay? So if you need help from me later, you'll have that jump start. Okay, number 14, intervals increase or decrease. I need my derivative. Okay, so cosine squared, pull the 2 down, leave cosine alone, and then multiply by the derivative of the inside, which would be cosine. Derivative of cosine is negative sine. So something like that. Then the minus 2 stays out front. Derivative of sine is cosine. So I'm just going to clean it up a little bit. This is negative 2 sine x cosine x minus 2 cosine x. And I'm going to set that to 0. If I set that to 0, I'm going to factor. So I'm going to factor a negative 2 cosine x out. And I should write that I'm doing this. So I'm going to write f prime of x equals 0 when, there we go, sneak it in there. So I'm factoring out a negative 2 cosine, so I'm left with sine of x here, and this would be a plus 1. And then we set each of these factors to 0. So when this is 0, it's just when cosine is 0. And when this is 0, wouldn't I subtract the 1 on over? So it would be when sine of x is negative 1, right? Now if you don't know your unit circle, it is worth memorizing or getting tattooed on your body somewhere, okay? All right, let's take a look here. So if we remember our unit circle, it should go cosine, comma, sine. So cosines are our x's. We're looking for when cosine is 0, so cosine is 0 up here, and cosine's also 0 here. And they say we're just going from 0 to 2 pi. So I'm going to go with x equals pi over 2, and x equals 3 pi over 2. And then we're trying to find where the sine is negative 1, and the sine is the y value. So we're looking at the y's here. And the y is negative 1 right here. So we already have that one, don't we? All right, now I'm trying to remember what we're doing here. Intervals of increase and decrease. So if we're doing intervals of increase or decrease, what are we going to do next?
You put a number line?
Yeah, the number line, right? So we're going to go ahead and do our number line. And we're really only going from 0 to 2 pi, and these are the spots that we have to cut them at here as pi over 2 and 3 pi over 2. So the only thing that you have to be, a little bit careful of here is when you plug in something smaller than pi over 2, you don't want to be like, oh, I'm going to plug in negative whatever, because we're going from 0 to 2 pi. So you want to plug in something between this 0 and then here is the 2 pi. You want to make sure that you're plugging something in that's in that interval, okay? Otherwise you might end up with the wrong sign depending on what value you picked there, okay? So we're plugging into the first derivative. So I'm going to write here, this is my first derivative. And if I plug in something between pi over 2 and 3 pi over 2, we could just plug pi into it. And we're plugging into the first derivative. I like using this factored form here. So I'm plugging into -2 cosine times sine of x plus 1. Okay, so if I plug in pi here, my cosine's -1. So if I have -2 times -1, I get 2 out here, so positive. And my sine's the y, so that's 0. So this would be 0 plus 1, which would be 1, right? So do you see how it's positive? And we only care about the sign. So that would mean that f is increasing from pi over 2 to 3 pi over 2. And there might be more intervals where it's doing that too. Okay, then if I plug something in between 0 and pi over 2, let's say I pick pi over 4 right here. Okay, if I look at the sine and the cosine, they're both positive, aren't they? So if they're both positive, this -2 times a positive is going to be a negative. And then in here, a positive plus 1 is going to be positive. So I end up with a negative there when I multiply those. So that would be decreasing. Everybody following? And then something between 3 pi over 2 and 2 pi. So let's say we pick this one here, the 7 pi over 4. Okay, my cosine there, cosine is the x-coordinate. So our x-coordinate's positive, which is going to give me a negative out front. And sine is negative square root of 2 over 2. If I do negative square root of 2 over 2 plus 1, is that going to be a positive or a negative in there? Think about the values on the unit circle. Okay, the values on the unit circle, isn't the biggest value it can be 1? And the biggest negative value it could be would be like a -1, right? So this value here, the square root of 2 over 2, it has to be less than 1 when we're thinking about how far it is, because it's the y-coordinate, how far it is from that y-axis, right? So if this is smaller than 1 as a negative, wouldn't this be positive in there? We have a negative times a positive, so we would get negative. You following all that? Okay. So then it's also decreasing from 3 pi over 2 to 2 pi. And maybe the key has it with like a boxed end point there. I've never seen a question on the AP test where that has come into play. I just always use the rounded ones because that's the way the AP ones are, but technically it would probably be like that. Okay. All right, so we got increasing, decreasing, and then part B is the maxes and min. So if I think about this point here, and I'm going to write the word local or relative. Okay, local max or min or relative max or min, those are the same thing. But if you just write max, it's like the absolute max. So make sure you're using the local or relative when we're like not checking for the absolute stuff. Okay, so there's a local what at this spot? Remember, we're decreasing here, and then this means we're increasing here. So min, thank you. So local min. And then here we're increasing and then decreasing. So if we increase then decrease, this would be a local max at this spot, right? Okay, so for part B, I'm just kind of piggybacking off of that there. Find the local max and min values of f. So we know that there's a local min at x equals pi over 2. And to find the value of that, we're going to plug it into the equation, right? So we'll do that in a second. And same idea with the local max at x equals 3 pi over 2. And to find the value, we're going to plug it in. So we're going to plug into the function, right? Because we want to know what the value of the function is there. So plug into that. All right, let me find the function. I'm going to move this unit circle out of the way so we got room. I don't know if we'll need it again, but we might. There we go. Okay, so our function was cosine squared. So what we're doing here is we're doing the cosine of pi over 2, and then we're going to square it. Minus 2 sine of x would be minus 2 sine of pi over 2. Everybody following? Same idea with 3 pi over 2. We're going to do cosine of 3 pi over 2 and then square that answer. Minus 2 sine of 3 pi over 2. There we go. Okay, so cosine of pi over 2 is 0. Cosine of 3 pi over 2 is also 0. So those go away. The sine of pi over 2 is 1. So this would be negative 2 times 1. So I get negative 2. So this would be our local min value. Okay, local min, that's our value. And then here we've got negative 2 and sine of 3 pi over 2. Okay, 3 pi over 2 on your unit circles down here. And the y-coordinate would be a negative, right? So we got negative 2 times negative 1, which gives us 2 for our local max value. Okay, and then let me look what else we got here, the intervals of concavity and inflection points. So how are we feeling so far about this one? I see Jaden had a question on how to start it. And Greta had a question. Greta, when you were doing this, did you have trouble getting parts A and B? Or was it really part C you had trouble with?
Yeah, I had troubles getting the thing because like the cosine and sine, I need to memorize the unit circle better, I think.
Yeah.
I like plugged the calculator instead of doing it on unit circle, and then it was super confusing.
Okay. So I'm going to stop here then, okay? So there's still part C to do, but do you see how to do part C? Kind of like what we did up here, right? It's like we're doing 2 parts of 2 different problems. You got to finish both the problems. So for part C, you're going to take your first derivative and take a derivative, set it to 0, number line with the second derivative, find the concavity and inflection points. Okay, and I know we didn't quite finish all of that, but hopefully that gets you moving in the right direction with those, and then we can get some more of these questions answered. Okay, so 12, 14, how to finish 16. So 16, find the local max and min values of f using both the first and second derivative. Which method do you prefer? Okay, so Chad, what was your question on 16? Was it for...
Well, I got the first derivative, and then I was just confused how to get the local max and mins from there.
From the first derivative. So it's like what we're doing here. So you have your first derivative, which might be messier, but you understand like the process of it. It's just hard because of this function. Is that what's happening? Okay. So I'm going to go ahead and start this, and I'll get my derivative. Don't tell me it, because sometimes if your well, and you probably checked it, but sometimes if your derivative's wrong, then we end up like down this dark path that we don't want to be down. So this is 16. I'm going to do, because we're going to do both the first and second derivative test, so we're going to do a first derivative and a second derivative, and this will lead well into our lesson for Tuesday anyway. So for my first derivative, all right, I'm doing low, d high, minus high, d low is just 1 over the bottom squared. And then I'm going to distribute this. All right, so we get just x squared minus 2x on top over x minus 1 squared. Does that look right, Chad? Okay. And then we're going to set this to 0 and all that. I'm going to go ahead and do my second derivative, but if you want to wait to write it down, that's fine. It'll be sitting here just while my brain's on derivatives. Okay, so I'm doing low. And then d high will be 2x minus 2. And then minus high. And then d low. So I pull the 2 down for d low, leave the x minus 1 alone, and then multiply by the derivative of the inside would just be a 1 there. And this is going to do the same thing as what happened with Mackenzie's question. Are you seeing what I'm talking about?
Gonna cancel stuff.
Yeah, the one piece will cancel. So here, our second derivative test might not be like, ooh, this was a great fun test for this problem because the second derivative is so messy. With the ones that we'll start on Tuesday, we'll use the second derivative test, but a lot of times they're polynomials, so they're a lot easier. But with this is the same thing that we talked about earlier, where we've got the 3 chunks. We got this one, and then this one. They all have that x minus 1 factor in common, so we can get rid of one of them. So if I get rid of one here, and one here, and one here, this is what I'm left with. And then you can clean it up a bit, okay? Okay, so let's clean it up now. So I'm going to FOIL these 2 pieces in the front here. I've got 2x squared minus 2x plus 2. And I'm going to distribute both this negative and this 2 through at the same time. So it's kind of like I'm putting the 2 up there and distributing it. So minus 2x squared plus 4x. Okay, and I've got a nice curved numerator. Okay, I'm not going to put the equal sign, I'm just going to do scratch work here, and then I'll write the denominator once I clean this up. Okay, so I've got this one and this one look like they cancel if I did this right. Oh, these cancel too, don't they? So my numerator is just 2. That's nice.
Wait, minus 2x and minus 2x, those cancel?
With the 4. With the 4.
Oh, okay, yeah.
Yep. Thanks for checking me on that, though. It'd be easy to do that. Okay, so I think this is what my second derivative is. And I might just check the key to confirm, because I don't want to be going completely off track here, but this is number 16. Just a second here. Okay, so second derivative, 2 over x minus 1 cubed, yeah. All right, so are we looking, is this looking all right so far? Okay, so I've just done my derivatives for 16. I haven't really done any of the, new work here, but the derivatives, some of them are complex like this, and getting them cleaned up so that you can use them is complex sometimes. So it totally makes sense if you were struggling with that, especially without having done this where we can cancel that factor piece out. Okay, but it cleans it up super nice. So now, I forget what we're doing here. Find the local max and min values of f. Okay, so the maxes and mins, if we're just doing the first derivative test, that's like what we were doing up here, where we put it on the number line and we see where it's increasing, decreasing, and then we find them. So it's exactly like what we did up here. So I'm going to set my first derivative equal to 0, and I'm going to factor an x out. So then I've got x minus 2. So wouldn't it be at x equals 0 and x equals 2? You guys okay with that? And then I'm going to set the denominator to 0 also, because sometimes there's weird stuff that happens there. So first derivative undefined. And wouldn't that be when x equals 1? That's when the denominator here would be 0. So then if I put that on my number line, we'll see what happens here. Okay, so we got 0, 1, and 2. And we're plugging into the first derivative. I'm going to use this here. And if we're looking at this, do you see how the denominator, no matter what it is, it's always going to be positive, isn't it? So really when I'm plugging in to figure out what the sign is, if it's positive or negative, I can just use this, or I can just use this, which I always like the factored form. I've got x and then x minus 2, because it's easy to see if it's positive or negative using this factored form. So I'm really just plugging into here. If I plug in something bigger than 2, like 3, it's going to be positive. If I plug in like 1.5, positive here, but negative here, you see that? So negative. If I plug in 0.5, positive here, and 0.5 minus 2 would be negative here. So it's not changing sign, which sometimes makes me go, okay, I got to make sure I did that right. But if I check this one and it changes sign, I usually feel pretty good about it. So if I plug in a negative, it'd be negative out here, negative in here, so it's positive. So what does that tell me about this point? Is that going to be a max or a min?
Neither.
Neither, okay, because the function's decreasing and decreasing again. There might be an asymptote there, stuff like that'll happen. And if we look back at the original function, wouldn't there be an asymptote at 1? Okay, but on both sides of an asymptote, things can change, like the increasing and decreasing and stuff like that. That's why I always want to put those on here. Okay, so that spot is nothing, right? But this spot here, the function is increasing, and I'm just going to write f here. F is increasing, and then it's decreasing. So if it changes from increasing to decreasing, this has got to be a local max, right? And then this one here, the function is decreasing and then increasing, so there'd be a local min. And it's asking not for the x values, but for the actual values, which would be the y's that go with it. So we're going to plug 0 in, and this is going to be the local max. So, and I'm plugging into the original function, so don't I just get 0? So our local max value is 0. And then our local min is when we plug 2 in. So if I plug 2 in, I get 4 over 1, right? Didn't mess that up. It's easy to mess it up. And sometimes people see this and they go, that makes no sense. The max and the min, right? Doesn't that seem weird? The max is 0, the min is 4. It's not an absolute max or min, and there's an asymptote at 1. So what's happening is we probably, and I suppose I could just type it in my calculator, because then I'm not going to embarrass myself with a terrible sketch here. Oh, I'm in a way different mode here. Just a second. But if you're like, okay, I must have done something wrong, that's not necessarily the case. And I know you guys have like the key, you can check that or whatever. But whoops, I don't think I switched it. Yeah, I did. Okay. But you can also just type this into your calculator and take a glance at the graph and make sure what you're doing makes sense. You wouldn't have that on the AP test, but whoops, I put to the 4th. I don't know what I was looking at. Okay, it should be x squared. Oh, I think I was looking down below. Okay, so x squared over x minus 1. All right, and if I go window, this is happening at 0, that's happening at 2, so maybe I go -2 to 4 or something. And I'm going to try -10 to 10, because sometimes that means zoomed out a little bit. Okay, let's take a glance. This asymptote here makes it weird, right? Isn't there a local max here? Do you see that? And isn't there a local min here? So does it make a lot more sense when you see the visual of it? The max is a max value of 0. The min is a min value of 4. It just is because of what those chunks of the graph look like, okay? So if you do get confused on that, sometimes throwing it in your calculator makes you feel, or makes it make a little bit more sense if you're confused, okay? All right, so that's getting part of 16. The other part of 16 is the second derivative test. So our second derivative test is we take our first derivative, we find where those issues are, okay? So with our first derivative, we had issues at 0, 2, and 1, right? And then what we do is we plug them into the second derivative. So if I find my second derivative at 0, 1, and 2, and make sure I grabbed the right values here, 0, 1, and 2, yep. At 1, there's just an issue, isn't there? And that makes sense. There's an asymptote there, so that I just always check it because sometimes we get confused and we're not sure if we should. I just always check it. What we're looking at for this second derivative test is it positive or negative? So I don't want you to write down the value because sometimes when we write down the value, we get it wrong, where if we just write greater than 0 or less than 0, we would have had it right, okay? So if I plug 0 into here, I would get 2, and you can kind of write it off to the side here, over 0 minus 1 would be negative 1, cubed would be negative 1. So I get a negative. So I'm going to say it's less than 0 here. And at 2, wouldn't it be positive? So greater than 0? All right, so what this is telling me, second derivative test, if you remember it, this tells me the concavity. So if the second derivative is less than 0, it's concave down, right? If the second derivative is greater than 0, it's concave up. And if the first derivative was equal to 0, wasn't there a max or min at that point? So this is going to be a local max at x equals 0. And this one's going to be a local min at x equals 2. Isn't that what we found up here? We're just finding it 2 different ways, okay? We should get the exact same answers as what we had up here. So what's the value? We find f of 0, which we already know because we did it, and f of 2, which we already know because we did it, okay? But do you see how there's 2 different ways to go about these? And when we start our lesson on Tuesday, today's lesson isn't so bad, but Tuesday's lesson's doing a lot of this stuff, okay? But it's the story problem aspect that's more difficult. So the questions, the equations aren't as complex as this, okay? For the most part. Okay, all right, so that's a lot of very good algebra question stuff. Then 18, find the critical number, second derivative test, tell you about the behavior. Yeah, 18 we'll probably look at here. I'm just trying to see if we got some different stuff. I mean, I'll definitely look at it with you at some point here. I'm just looking to see if we got something new too. And 18 is a little bit new, but it's similar to what we did there in 16. So we also got 40, 53, and 56. I'm just looking in my book here. Okay, so 40 is similar to what we did today. Jaden, how do you feel about 40 now after we did, I forget which one had that, number 14. Do you feel like you could give it a try and then work with me during flex maybe if you're still stuck? Okay, because I know it's got the trig stuff in it there. And unit circle, if you just Google unit circle, you'll find one. Okay, hopefully it's correct. You might want to Google it and double check with another one or something, but you can find yourself a unit circle pretty easily. How many people feel like they could use a lesson on the unit circle over Christmas break or winter break? And it's not like I would be like, this is mandatory. But I feel like anyone who skipped calculus this year should be raising your hand hardcore, I feel like both hands should be up, right? Don't you feel like unit circle stuff would be nice to know a little bit better? So I'll try to come up with some sort of like mini lesson type thing where you can watch it and hopefully it starts to make a little bit more sense for everybody. I feel like that might be something I send to my BC kids too, because it's just so easy to forget a lot of that stuff. It won't be anything that's like mandatory, but if you don't do it, that would just be silly in my opinion, okay? All right. So it won't be necessarily homework over break, but that would be all you'd have over break then. All right, so that takes care of that. Which one was that? 40-ish. You know, you might have questions still, and we can look at them during flex. And we got 53 and 56. Okay, 53. While I really like it, I might save that one. Yeah, 53 and 56 they're such good questions and concept. 53 has like too much going on with it is the problem, but I'd like getting it set up. 56 though, let me grab it here. 56 just seems so much like an AP problem, but a difficult AP problem, don't get me wrong. It's not like, oh, you should know how to do this because you're an AP or anything like that type of AP problem. But it's definitely very AP-like in that we go, okay, I'm not quite sure what to do here. So let's try to figure this out as a group. I'm assuming most people didn't finish this one, otherwise you might have jumped to the key to try to get a clue for it. There maybe were a couple of you where you're like, okay, I need to do this possibly, and you got to start to it. So let's kind of work on this as a group. For what values of A and B is this an inflection point? So when you see inflection point, what's something that you should probably do if this was an AP problem?
Second derivative?
Yeah, you need your second derivative for anything involving concavity or inflection point, right? So even if you can't get to the answer, you're going to get points for your derivative. So let's get our derivatives here. So using this, well, what do I have to use in order to take the derivative of that?
Implicit differentiation.
Implicit, right? Our implicit differentiation with the product rule, you might have been thinking product rule there. That's also correct here. So we're going to do our first times the derivative of y. Derivative of y would be 1 dy dx. Plus the second times the derivative of this would be 2x. So that's just that first piece, right? Now we move to this piece here. What is the derivative of ax? Just a, it's a constant, right? Thank you. And then same kind of idea with b times y. It's going to be b times 1, but then we need a dy dx, right? And then equals 0. Derivative of 0 is still 0. Okay, so this is just going to give me the first derivative. So I'm going to get dy dx by itself. If you remember, to get dy dx by itself, we're going to move these things to the other side. So let me just do that right away. Negative 2xy by subtracting it, and minus a, subtracting it. And then factor out a dy dx. And then we divide this over, right? Everybody okay with what's up there right now? Okay, then to get the second derivative, we take the derivative of this. So it's written d squared y over dx squared. If you're ever nervous that you're gonna like write that incorrectly, just put y double prime, okay? They're the same thing. So if you're writing it and you're just nervous you're gonna put the squared in the wrong spot or something, just do y double prime. Okay, so over here I'm gonna do low d high. So low is x squared plus b. D high, I've got to do the derivative of this, so I'm going to split it up for product rule and do implicit again. So I've got my first times the derivative of the second would be dy dx plus And then I do the second is just y. And the derivative of the first, wouldn't it be -2? So we could have that, or can I just rewrite that as -2y? Is everybody okay with me doing that right now? Does anyone have questions on where that came from? I know it's hard to stay focused, or if it glitches, you miss something. All that stuff is making learning a little bit harder, right? Okay, so I think that looks good. So that's just low D high, right? Because the -a goes away, doesn't it? And then we got to do minus high D low still. So that's minus high, and then D low is just 2x. So it's nice that that one's not crazy. Over the bottom squared. All right, that's beautiful. I am going to, I don't like this dy dx sitting in here. Does anyone have an idea of what I could do with that? Might not be a very fun idea for some of you, but, or for any of you, let's be honest. We need to take this dy dx and plug it into that spot. This is beautiful, isn't it? Like, I mean, like, be honest, okay? We all enjoy this problem. Okay, so let's think about the goal of this problem, but that is what we're going to do, okay? We're going to plug this piece into there. But let's just think about the goal of this problem. So for what values of a and b is this an inflection point of the curve? So what, where are inflection points going to happen at? What am I going to have to do with the second derivative?
Like find the concavity?
Yeah, so we're going to have to find where the second derivative is equal to 0, right? And then it's where it changes signs. So really, hopefully this numerator cleans up a little bit. But what we're trying to do is we're going to set this numerator to 0 to find that inflection point. And we know the inflection point, right? We know the inflection point is 2 and 2.5. So we know our x and our y that are going to make this 0. So even though it seems like terrible right now, think about taking all the x's and replacing them and all the y's and replacing them, getting numbers. It's going to be a lot easier, and then we're going to set it to 0. Do you see what I mean? And it's still, I'm not saying it's easy from here on out, but if we think about what we're doing, like, we can get there. We're strong math students, right? So I'm going to keep this factored for right now, and I'm not going to put an equal to. I'm just going to put the numerator, because I'm setting the numerator to 0 to find my inflection points. So I've got my x squared plus b. I'll be replacing those in a little bit. And here I'm just going to kind of leave it a mess. Negative 2x times this mess up here. Negative 2xy minus a over x squared plus b minus 2y. And I suppose here I can, maybe I'll distribute the negative just to have those be positive, but then I'll leave the 2x in a parenthesis and this stuff in a parenthesis. Do you guys see what I did there? Just to get rid of some negative stuff. So I have the 2x, and then these I just ended up making positive. And really I'm trying to find when this is equal to 0 at x equals 2 and y equals 2.5. We're going to see if maybe this helps. Okay, so let's plug these in.
Wait, wouldn't you have to distribute the negative also for the 2x and back? So that turn negative?
No, think of it this way. So if we have this big chunk here, let's just reorder it. If I have the negative out front, and then I've got the 2x here, and then I've got the negative 2xy minus a. Okay, if we take this is like -1. If we have A times B times C, we don't go A times B and A times C, do we? All we did is we just took A times C and we just left the B there, I guess. We could think of it that way. You could also leave it as a negative and leave these as a negative. You get to the same spot. I don't know that I would expect you to necessarily do that and not make an error, so. Okay, so let's plug these in then. X squared is 4 plus B. -2 times x gives me a -4. This stuff here. I'm going to get my calculator. I don't want to mess up. Go ahead and grab your calculator. Start plugging stuff in. We'll see if we get to the same spot. Well, I feel like I could do this with mental math. I really don't want to mess up at this point in the problem. Okay, so I'll mute myself so I don't keep talking to you guys. 2 times 2.5. Once I get to this point, I'm seeing something here that I want to just take care of. If I take this factor here and I distribute it to both of these pieces, do you see what's going to happen when I take it times this piece here? That 4 plus b is going to cancel this 4 plus b, right? And then it's not going to cancel back here. So I'll get rid of those lines. So I'm just taking this one times this one right now. So those will cancel and we get -4 times -10 minus a. And we can distribute that -4 through at any point in time. Does everybody see what I did there? Then I'm going to take this times what's in the back. So now I've got a -5 times 4 plus b. And then this I'm just going to distribute now. Let me know if I mess something up or if something doesn't match. And then I'm going to distribute these pieces next. We're going to see if this gets us somewhere close. I'm just crossing them off while I write them down so I don't miss a term. Okay, I'm not like canceling them. All right. It's not what I was hoping for, but it's getting us to the answer here. And none of the AP questions are going to be this much work in one like piece of a problem, okay? If they were, it would just take way too long, but all these little things can show up, like this knowing that it's a second derivative and you're setting it to 0, and sometimes you're trying to find an a and a b value, but the problem's simpler. So all these things are like good to have. Now, if you recognize this here, we have 2 variables, right? This is like going to turn into like an algebra 1 problem, but we only have half of it. If you have 2 variables, you need to have 2 equations. So we're missing something in the problem here to come up with our other equation. Does anybody have any idea what it is? If you read the problem again, somebody might go, can we try this?
Is it something with the point itself, 2 times 2.5?
Yep. Won't this point, if it's an inflection point, won't it be on the equation? So what can we do then?
Plug that into the equation, the original.
Yeah, plug it right into here, and then we're going to get our other like piece of the puzzle here to finish solving. Okay, now I guarantee this is like the calculus stuff of it, right? And then this piece here is like the, oh duh, like the part that you miss a lot of the time. So if we're plugging x in and x is 2, we get 4, let me make sure I don't mess this up, 2 squared times y, so times 2.5, we get 10, plus a times x would be 2a, plus b times y, 2.5b, equals 0. Does that look right? And now I've got 2 equations and 2 variables. So I'm going to rewrite this as, I'm going to write it down here so I can see it when I scroll. 2a plus 2.5b equals negative 10. I'm just going to write it right below this one. 2a plus 2.5b equals negative 10. And now we're trying to solve for a and b, so I would probably take the bottom equation and times by 2. Do you guys see why? For the elimination method. Depends how long it's been since you've done that. But the bottom equation, if I times by 2, I get 4a plus 5b equals negative 20. Then I'm taking the top equation and this bottom equation and adding them together. The 5b and negative 5b cancel. We get 12a equals negative 80. Okay, and if I do 80 divided by 12 in my calculator, I'm getting a is negative 20/3. Whoops. Stopped writing for some reason. There we go. And then to get the b value, what would we do?
Plug it back into the one that doesn't matter, right?
Yeah, one of those, right?
A minus 5b.
So yeah, we can plug it back into either of these. I'll just go with the blue because I'm writing with blue. So we do 8 times a minus 5 times b equals negative 60, and then we just solve that. And you can use your calculator. 20/3 times. I'm getting an answer for B of 4/3. When it's all said and done there. Not positive it's all right, but if it's wrong, we're not redoing the problem, okay? You see some of the stuff in there? Okay, sometimes it's not super obvious what to do, but when you see inflection point in a problem, you want to get your second derivative, okay? When you see concavity in a problem, you want to get your second derivative. When you see increasing, decreasing, maxes, mins, you want your first derivative, right? These are important things to just like have in your head for when you see those words. Make sure you're doing those pieces because they'll get you started on the problem. And then sometimes things fall into place really easy. Sometimes they're complex, but typically the crazy complex ones will be book ones. Okay, the AP stuff is more of like, oh, there might be a tricky part in the problem, but there's not like so much algebra if it's a tricky problem. They usually give you nicer numbers in those, okay? Let's see. Let's just cross 56 and 54 are kind of similar, or not 54, 53, sorry, are kind of similar in thought process. We might go back and try to set it up at some point, but let's not do that for this assignment. So go ahead and cross off that one for now, 53. Okay, and if you have more questions, which I am guessing you do, we can work during ESR today. So you can just stay connected and I can work with you more on this 3.3 stuff. 3.3 is a very important lesson. So if you might have like, okay, I didn't know how to do any of the problems. If that's the case, I can just work through some more problems with you there. Whoever stays connected will do the problems like where I just have one question because you got most of it done. Because the people who have a lot of questions probably have questions on those ones too, and then we'll just work back to other things. And then also flex time this afternoon. If you need more help, just ask during to be connected during flex too, okay? All right, so if you don't submit that right now, that's all right. We'll get there. Just try to submit it if you can by the end of today, because you could work with me during flex time. And if you work with me during flex time and you still need more time, you know, get it submitted before your next class period so you can get to the quiz and stuff too that we might have. Okay, I think that was the
Could
notebook
you
I wanted.
possibly record those?
Any questions people have?
Yeah, because I have my CNA exam, so I won't be able to.
Yep, that's fine. And that's why I was recording this one too. So I'm going to go ahead and stop my recording here. But this